of Management Studies IGNOU presents an audiobook on the course MMPC 015 Research Methodology for Management Decisions for MBA program. Presenting Block 3 Data Presentation and Analysis, Unit 10 Multivariate Analysis of Data.
Objectives. After studying this unit, you should be able to 1. Explain the concept of association that takes place between a dependent variable and a set of independent variables. 2. Describe the various multivariate procedures available to analyze associative data in the context of any research problem. 3. Interpret the findings of multivariate analysis in any research study. And 4. Use a particular technique of multivariate analysis suitable for a particular business research problem. Introduction. In MMPC 005, we have covered the fundamentals of statistical inference with special emphasis on hypothesis testing as an effective tool for business decisions. Univariate analysis forms the foundation for the development of multivariate analysis, which is the topic of discussion in this unit. While the concept of univariate analysis will continue to draw our attention time and again, our focus in this unit will be on procedures of multivariate analysis, which has emerged as the most striking trend in business research methodology. Description and analysis of associative data involve studying the relationship and degree of association among several variables, and therefore, multivariate procedures become imperative. We shall attempt to highlight the procedures. We have discussed here 3 multivariate techniques, namely regression analysis, discriminant analysis, and factor analysis. Regression analysis finds out the degree of relationship between a dependent variable and a set of independent variables by fitting a statistical equation through the method of least square. Whenever we are interested in the combined influence of several independent variables upon a dependent variable, our study is that of multiple regression. For example, demand may be influenced not only by price but also by growth in industrial production, the extent of import prices of other goods, consumers' income, taste, and preferences, etc. Business researchers could use regression for explaining percent variation in dependent variables caused by a number of independent variables and also problems involving prediction or forecasting. Discriminant analysis is useful in situations where a total sample could be classified into mutually exclusive and exhaustive groups on the basis of a set of predictor variables. Unlike the regression analysis, these predictor variables need not be independent. For example, one may wish to predict whether sales potential in a particular marketing territory will be good or bad based on the territory's personal disposal income, population density, and number of retail outlets. You may like to classify a consumer as a user or non-user of one of the 5 brands of a product based on his or her age, income, and length of time spent in his or her present job. Here the interest is what variables discriminate well between groups. Factor analysis provides an approach that reduces a set of variables into one or more underlying variables. The technique groups together those variables that seem to belong together and simultaneously supplies the weighing scheme. For example, one may be interested in the identification of factors that determine the company's image. When the decision maker is overwhelmed by many variables, the factor analysis comes to his or her help in compressing many variables into few meaningful dimensions, like service orientation, quality level, and width of assortment in a research project involving 20 retail chains on 35 factors or variables. Regression analysis. Regression analysis is probably the most widely applied technique amongst the analytical models of association used in business research. Regression analysis attempts to study the relationship between a dependent variable and a set of independent variables. For example, in demand analysis, demand is inversely related to the price for normal commodities. We may write D is equals to A minus BP, where D is the demand, which is the dependent variable, and P is the unit price of the commodity, an independent variable. This is an example of a simple linear regression equation. The multiple linear regressions model is the prototype of the single criterion or multiple predictor association models, where we would like to study the combined influence of several independent variables upon one dependent variable. In the above example, if P is the consumer price index and Q is the index of industrial production, we may be able to study demand as a function of two independent variables P and Q and write D is equals to A minus BP plus CQ as a multiple linear regression model. The objectives of the business researchers in using regression analysis are 1. To study a general underlying pattern connecting the dependent variable and independent variables by establishing a functional relationship between the two. In this question, the degree of relationship is derived, which is a matter of interest to the researcher in his or her study. 2. To use the well-established regression equation for problems involving prediction and forecasting. 3. To study how much of the variation in the dependent variable is explained by the set of independent variables. This would enable him or her to remove certain unwanted variables from the system. For example, if 95% of the variation in demand in a study could be explained by price and consumer rating index, the researcher may drop the other factors like industrial production, the extent of imports, substitution effect, etc., which may contribute to only 5% of the variation in demand, provided all the causal variables are linearly independent. Discriminant analysis. It has been pointed out earlier that the discriminant analysis is a useful tool for situations where the total sample is to be divided into two or more mutually exclusive and collectively exhaustive groups on the basis of a set of predictor variables. For example, a problem involving classifying salespeople into successful and unsuccessful, classifying customers into owners or non-owners of the videotape recorder are examples of discriminant analysis. Objectives of two-group discriminant analysis: 1. Finding linear composites of the predictor variable that enable the analyst to separate the groups by maximizing among groups relative to within groups variation. 2. Establishing procedures for assigning new individuals whose profiles but not group identity are known to one of the two groups. 3. Testing whether significant differences exist between the mean predictor variable profiles of the two groups. 4. Determining which variable account most for intergroup differences in mean profiles. Factor analysis. Factor analysis is a generic name given to a class of techniques whose purpose is data reduction and summarization. Very often, market researchers are overwhelmed by the plethora of data. Factor analysis comes into their rescue in reducing the number of variables. Factor analysis does not entail partitioning the data matrix into criterion and predictor subsets. Rather, interest is centered on relationships involving the whole set of variables. In factor analysis, 1. The analyst is interested in examining the strength of the overall association among variables in the sense that he or she would like to account for this association in terms of a smaller set of linear composites of original variables that preserve most of the information in the full data set. Often, his or her interest will emphasize the description of the data rather than statistical inference. 2. No attempt is made to divide the variables into criterion versus prediction sets. 3. The models are primarily based on linear relationships. Factor analysis is a search technique. The researcher decision maker does not typically have a clear prior structure of the number of factors to be identified. Cutoff points with respect to stopping rules for the analysis are often ad hoc as the output becomes available. Even where the procedures and rules are stipulated in advance, the results are more descriptive than inferential. The procedure involved in the computation of factor analysis is extremely complicated and cannot be carried out effectively without the help of a computer. Packages like SPSS, SAS, and biomedical programs (BMD) can be used to analyze various combinations leading to factor reduction. We will make an attempt to conceptualize the scenario of factor analysis with emphasis on the interpretation of figures. Summary. In this unit, we have given a brief introduction of the multivariate tools and their applicability in the relevant problem areas. We started the discussion with the regression analysis, which is probably the most widely used technique among the analytical models of association. We have started the simple linear regression model, first to introduce the concept of regression, and then moved on to the multiple linear regression mode. All the underlying assumptions of the model have been explained. Both the bivariate and multivariate regression models have been illustrated using the example of preference rating as a function of protein intake and vitamin D intake perception in the case of a ready-to-eat cereal. The concept of testing the linear equation, the contribution made by regression in explaining variation in dependent variables, and the strength of association have all been explained using the ANOVA table. A brief account of the role of regression in sales forecasting involving time series analysis has also been given. The need for resorting to computer solutions for a large number of variables and observations has been brought out with an actual printout of the example already discussed. The concept of stepwise regression and the problems encountered in any regression analysis have also been explained. Next, we have gone to the discriminant analysis technique, a technique when the interest is to classify the groups on the basis of a set of predictive variables. We have explained the concept of separation by giving examples of classifying salespeople into successful and unsuccessful, customers into owners and non-owners, etc. As before, we have begun the discussion with the discriminant function involving two predictive variables using the example of ready-to-eat cereal problem, but with the difference classifying the persons into liker group and disliker group. The discriminant function, the discriminant criterion, and the assignment rules have all been explained. Testing the statistical significance using the F-test based on Mahalanobis D-square has also been carried out. We have pointed out that the multiple discriminant analysis involving more than two predictor variables require the use of a computer, although the basic structure of the model does not change. Factor analysis is the last multivariate tool that we have discussed in this unit. We have first mentioned that the fundamental objective of factor analysis is to reduce the number of variables in the data matrix. Then, it has been pointed out that the computation of any factor analysis involves very complex calculation, which will have to be solved using computer packages like SAS. The concepts of factor loading, variance summarized, and communality have been explained using one practical example that has been solved by SAS program. The subjective issues like how many factors, what criteria to decide this number, and labeling of factors have been mentioned at the end. As concluding remarks, it may be mentioned here that 1. All multivariate procedures can be more effectively solved using standard computer packages when the number of variables and number of observations increase significantly. 2. What is more important is the ability to interpret the results of the market research study involving multivariate analysis.
You were listening to the audiobook by the School of Management Studies IGNOU for MBA program. Course code Mmpc 015 Research Methodology for Management Decisions. Course Coordinator Dr. Venkataya Chittipaka, Associate Professor from School of Management Studies IGNOU. Voiceover by Renuka. Edited by Savita. Program assisted by Tarannum Jahan and Jagbandhu Jana. Program produced by Dr. Manoj Kumar Singh. This program was brought to you by Electronic Media Production Center of Indira Gandhi National Open University.